In Chapter 5, Lesson 3, we want to look at the concept of variables, which is very central to programming. Without variables, you basically couldn't do anything, really. And specifically, we want to look at two types of variables, int and string. And then we want to look at a special type of variable called an array, which is actually a lot of variables all having the same name, and then qualified by what's known as an index or a subscript, which is a number which allows you to look at the variables with the same name, but actually different memory locations. And then we want to look at the concept of loops, which also is extremely important in computers, because what computers do very well is repetitious things over and over again with a slight variation. Can do that infinitely faster than a human can. And the two types of loops we want to look at are for loops and while loops. And then there's a type of file I/O that is actually the beginnings of our working on our main program. And that file I/O is called stream, and specifically a call to a system function called stream reader, which is in the namespace system.io. So it's a lot to cover in one lesson, so we better get started. What a variable is actually a location in the computer's memory, which you reserve for use of the program. And in order to know how to reference it, you give it a name. But from the computer's point of view, more than a name, it has an address, which is a number of the location. And numbers would actually be much bigger than this, but for sake of discussion, we'll say the address is 1,000, and that contains a value that we've given the variable, say 123. And if this variable is of type integer, it means it takes up 4 bytes. A byte is 8 bits, if you remember our discussion on bits. So you put 4 of these 8-bit packets together, and you get 32 bits, or 4 bytes. And the addressing scheme just addresses to the byte, not the bit. So the next location, if we've reserved an integer here, would be 1004. And we put a 5 in that. And then we have 1008, and we put a 17 in that. 2012, and we put a 5,765 in that location. And these numbers are in no way fixed. That's why they're called variables, because they vary. And we could at any time reference the name that's location 1012 and change this to 10 or 5,000 or whatever value we want to put in it. Since it's an integer, we're restricted to integer type values. But how does this definition of variables look in our actual CSharp program? I've written a short program just to illustrate this. It's not really part of the sub-programs that go into the main program, but just something to help us to learn the concept. And as you see, I usually put a boilerplate describing when I created a file and the name of it and how to build it, in case I forget about the CSC compiler, which I've done on occasion. And then we have our using statement with a name of system, which allows us to write shorter names. Since we're using a console write line, we don't have to write out system.console.writeLine. Not that bad if you just have one, but when you have a bunch of them in a program, it's a lifesaver. And then we have our our standard predefined function that has to have the name main, because that's what the compiler and the execution is going to look for, that established name. And here we have actually arguments specified, which is unnecessary. If we had arguments we were typing in from the command line, it would be received in this variable args, which is actually an array of strings, which we're about to discuss after this. It's the very next thing we discuss, actually. And here within the function main, we have our first two variable definitions. The first one is int num, which defaults to being the 32-bit memory location I mentioned. And as soon as we say this in the program, the compiler will assign a memory location to num, and then we can start putting numbers in that location to our heart's content, or changing the numbers or doing whatever we want with the numbers. And then a second type of location is reserved called string, and that's reserved to a variable named r. So if we want to put something in that variable, we have to use an assignment statement, as we do down here, and give it a string value. And the way you can tell it's a string value is it's deleted with double quotes. So we always have to have double quotes around the constant we're assigning to a string, and the reverse is true of a value we're assigning to an integer. It has to not have double quotes, and it has to be an integer, valid integer value, like 123 in the case of this. So in the first statement we're assigning the variable num 123, and in the second statement we're assigning the string the value organization is the key to success. And then the only other thing we do in the program is write this out to the screen, since basically the program's just teaching us the concept of variables. And we have a console.writeLine, and then this is a variation in writeLine, where you have a template string at the beginning. This is a template string here, and the string can contain literal values that are just displayed on the screen the way a regular writeLine works, or it can reference variables after the template string. And these variables are separated from the string by a comma, and the first ones are variable str, a string variable, and the second ones are variable num, which is an integer variable. And within the template string, you'll notice there's placeholders, or places where we want to put the value that's in these variables. And the way these placeholders are defined is a left brace, and then the number, which is a position they are after the string. And this is zero based. So left brace 0, right brace refers to the variable in the first position in the string, and left brace 1, right brace, refers to the variable in the second position after the string. So it's saying write Fyodor Dostoevsky, then write the string value after it, and then we have a /n/n, which are code characters for new line, saying add 2 new lines, and then write the literal value number equals, and then write the variable, the value that's in the variable in the second position, which is num. So if we go to a command window, or command prompt, or a DOS box, you'll notice I have this incredibly long, there's almost not room for me to type at the end of it anymore. It's what I call overqualified. But what we want to do, well, let's do a directory listing and see what programs we have on here. We have 3 programs that we're going to use this lesson. One's vars.cs, which is the variable program we just looked at. Then we have ars.cs, which helps us understand arrays, which we're going to look at right after this. And then we have file read.cs, which introduces the stream reader system call. So the one we want to compile is vars.cs. So what we're going to do here is go to the command line and type csc vars.cs. Hit return, and very quickly, since it's a really tiny program, we get the program compiled, and we get an exe file that has the same name of the .cs file. So if I do a directory now, there's the same 3 .cs files, and now there's the vars.exe. And in order to execute that, we just type the name of the exe file, which is vars, and we see the actually 2 lines, or 3 lines if you count the blank line. One has Fyodor Dostoevsky : which was in the template string, and then we have the value of the first variable str, which is organization is the key to success, which I think was said by Fyodor Dostoevsky, although I'm starting to doubt that as time goes on. And then it actually continuing in the same template stream, but with 2 line feeds based on those 2 /n control characters we put in it. We have number equals, and then we have the value in the second variable, num. I think the name of it was num. Let's see. Yes, value was num, and that the value of num was 1, 2, 3. So that's printed out. So that more or less covers our discussion of variables. If you're totally new to this idea, you might want to replay this lesson. You might want to play it as many times as you need to until it starts to really sink in what I'm talking about. As Tony Robbins always says, repetition is the mother of skills. Our second illustrative program is called ars.cs, A-R-I-S, and I forgot to rename the class ars. I like to have the class name the same as the executable name, although, as I've demonstrated many times, you don't have to. And we come down, and now we have a new type of variable defined. It's an int, but it's a different flavor of int. And what it is an array. What makes it array is these 2 empty square brackets. It says I want integers, but I want not just one integer, I want a lot of integers, and they'll all have the same name of num. And once we've declared an integer array like this, we then need to allocate space to the integer array, which we do in the second line, where we say num equals new int square bracket 10 square bracket, and that says allocate 10 positions in a row and give them all the name num. And now you're probably saying, if they all have the name num, how do you know which one you're accessing? And the answer to that is in this assignment statement down here. What you have is a qualifying number that says which of the nums you want to access. And this also is 0 based. Most things in C are 0 based. So the first one is num square bracket 0 square bracket. The second one's num square bracket 1 square bracket, and so on. Right now in this statement we're referencing the 6th one, which is a 5. So we say num square bracket 5 square bracket equals 66. And then I have a console write line that writes out num square bracket 5 square bracket. So it should write out the value we just put into that variable, 66. And that's one way you can assign what's known as members of an array. But it's not very efficient, and it's probably not what you want to do, because if you're using arrays, you probably want to work with a lot of values at once. And in order to do that, you use what's called a loop. And there's several types of loops. We're going to look at two different types of loops in this lesson, for loops and while loops. And the format of the for loop is shown here. First of all, we reference another variable, ix, defined up here as int ix. And there's actually three parts to what's inside these parentheses after the for. The first part is ix equals a 0. And that's what you want to do at the very beginning of the loop. You want to assign the variable ix a value of 0. And then the third part of this, which we probably should look at second, is ix++. And ix++ is a special form of statement. It's called auto increment. And what ix++ is really saying is ix is equal to ix plus 1. It's always adding 1 to the variable. And I ought to get rid of this so we don't mess up our program, although it wouldn't really. And so if we initially assign a 0 to ix, the first time the auto increment is implemented, it will actually change that 0 into a 1. And since we're in a loop, this is going to be executed a number of times. So the second time it's executed, it'll turn the 1 into a 2, turn the 2 into a 3, turn the 3 into a 4, and so on. And then the middle condition we have in a for loop here basically is really important because we don't want this to execute forever, which often happens by accident. And it says keep executing this loop as long as ix is less than 10. So basically this is going to start executing at 0, go to 1, go to 2, go to 3, go to 4, and so on until it reaches 9. And it'll keep executing through all those, but then when it's auto incremented up to 10, it'll look at this statement and say ix is now not less than 10, so I'm going to not execute this loop. I'm going to stop executing and I'm going to fall through to the next statement after this loop. So basically this assigns ix the numbers 0 through 9 in a loop, one at a time. And each time it does that, it executes the body of the loop, which is defined in these braces. And here we have another reference to our array, but instead of having a hard-coded number, we use the variable that we're using as the loop counter. So we say num subscripted or indexed by ix. So the first time this executes, ix is going to be 0. So we say num0 equals 0 plus 20. Then the second time this executes, ix is going to be 1. So this statement will say num1 equals 1 plus 20, which will be 21. And the third time it'll be num2 equals 2 plus 20, and so on. And then in order to see what we've done, what we need is another for loop. So the second for loop is identical to the first for loop. No need to dwell on that. and it's also going from 0 to 9, but this time it's printing out to the screen using the console write line. And what it's printing out is our template string with our variables referenced, and it says array member indexed at, and then it has the variable that's after this string in the first position, which is ix, since 0 is the first position variable after the string. So it's saying array member indexed at ix value is, and then I have the array referenced by the variable, which is incrementing in the loop, remember, so it'll be 0, then 1, then 2, then so on, all the way up to 9. So I'm saying the array value num square bracket ix square bracket. So why don't we compile and execute this and see how it looks. I've typed in once again cscrs.c. Now I hit enter and it compiles, and now I type ARRS in order to execute the exe that I just produced by the compile. And we see first it prints out the number 66, which was the array value, which is the array value we just assigned directly. We said num square bracket 5 square bracket equals 66, and then we printed out num square bracket 5 square bracket. So that worked correctly. And now we have our loop where we say array member indexed at 0 is 20. So in this loop we'd gone through and said num 0 equals 0 plus 20, which is indeed 20, and then 1 plus 20 is 21. So these assignments worked correctly, adding 20 each time to the index. And then when we printed it out with the same type of for loop, we see that it indeed signed the values just as we expect based on the index value and into the array member that's referenced by the index. Alright, on to the third and final part of the lesson, where we actually make a system call that we're going to use in our final program. This is a program called fileread.cs, and I have my usual header, and this time in the usings I have not only system using system excuse me, but using system.io, and that's because the call we're going to use later to StreamReader, actually to a StreamReader object we're going to instantiate, is qualified by system.io. It's really system.io.StreamReader. And when we come down to our main function, you see we instantiate an object, which means we specify the object name, which is StreamReader, or the class name, and then we give the object our own name for this specific instance, which here we're calling RE for read. So we say create an object based on the StreamReader class and name it RE. And then we say that's equal to file.open, and then we have a parent, and we have an @ sign, and basically the @ sign allows you to use special characters. Specifically, it'll allow us to use a backslash, which, as you saw from the \n, backslash is usually or often used to specify a special control character like a new line. So I say @ sign double quote for a string, and then you have c:/.net/Doug teaches / Athena, and so on, the whole directory name up to orgbat file. And then we have a text file, which is the actual name of the file, which is aathena.txt that we've talked about previously. And what this call to the file object, which is a file, is a static class. We're talking about static classes being able to exist by themselves. You don't have to instantiate them as objects. So it says file.openText means open this file so I can start to access it, and assign that open file to a handle I have in my program used to access it, which is a stream reader object named RE, which will be made up of methods and possibly properties that I can readily manipulate this file now that I've opened it. And then we have another variable that's of string type, which is named input. So I say create a variable named string and give it a value of null. And it's important we give it initially a value of null. Actually, it'll probably default to null, but it's still important that we give it a value of null because we're using another type of loop, a while loop here. And the while loop says keep executing this while this condition is true. And right after we assign a null value to input, we reassign a value to input in this statement, which says use the stream reader object we created dot a method within this object called readLine, which reads the line in the file that's currently being pointed at. And when you first open a file, the first line is being pointed at. So this says read the first line from this file we opened in a couple lines above into the variable input, and it'll either read a line into input, or if it's run out of lines, it will assign input a null, which says I've reached the end of the file and there's no more lines to read. So in the while loop, we're checking to see if input is null. The exclamation mark equal in C means not equal, and two equal signs together mean equal in an assignment statement. And then there's others such as less than, which we saw earlier, and less than or equal, and greater than or equal, and various comparison operators we can use like that. But in this case, we're saying while the variable input is not equal to null, which it shouldn't be if we read the first line in, it should be the string that's the first line, fall through and do what the body of the loop, which is defined within these curly braces that are right after the while command. So the first line of what we do inside the loop is a console.write line, and it writes out the variable input, which should be a string value that the first time through the loop should be the first line of the file. And then the second line in the loop, we do the same operation again. We assign input a read line value from the file, which says the second line is currently being pointed at, because when I did the first read line, it read into the input variable and it moved the pointer to the next line. So when I do this read line, I'll read in the second line, and now input has the value of the second line. Execution falls through to the brace, and it says go back to the top of the loop, check the while loop. Is input still not equal to null? Well, if there was a second line, input will still not be equal to null. So we'll fall through again, and we'll do the console write line again and write out the value of the second line. And we'll keep doing this as long as there's lines, which there could be 1,000,000 lines. That's the value of computers. You know, it'll just keep executing the loop as long as there's data to keep it going. And so once we do reach the end of the file, it comes down to the bottom. It does a read and gets a null because we're out of lines. Comes to the brace, end brace, which says go back to the loop. Checks the input, and is the input not equal to null? Well, that's no longer true because input is now equal to null. Statement is false. Input not equal to null is false because input is equal to null. So it falls out of the loop and goes to the next line in the program, which is just a return 0. And the reason we have a return 0 is up here we have an int value for the return value of main instead of void. It's probably unnecessary to have it return any value, but it's a good illustration of what the meaning of that item in the line for the function is, which is a return value. So it returns a 0, which basically means the program stops running. It hits the end of the function and the program stops running. So let's compile this and see how it works. Go once again to our DOS box or command prompt window and type in CSC. I forgot the name of the program already. It's file read.cs. CSC file read.cs and hit enter, and there's no errors. Oh, thank goodness. And then to run the file, you just type the name of the exe file we just created. So we type file read, and boom, we get a ton of lines printed out, which are all the lines from the file we specified in the open text. Over here we see the open file.openText and then the name of this file, which is aathena.txt. So all the lines from that file are now printed out on our screen. The first line was camstudiotutorial.flv and so on. It goes through each line in turn, and when it runs out of lines, it falls out of the loop and stops executing. The program ends. So the last line in that file is wordpress.com step-by-step tutorial on how to blog.flv. So we've successfully executed our stream reader using the file open text and also the read line, the two main system functions referenced in the program. Really, we could also have done a re.close. Probably should have, but when you exit the program, it automatically closes file handles, and since there's virtually nothing the program, I have some comment here that it doesn't work, but I'm pretty sure it does work. So I'll delete that, save it, and what we could have added here at the end is re, which is our stream reader object dot close parent, and that would close the handle we opened with the file.openText and used for the read lines. And if you have multiple files, as you'll see later on when we start developing the program more and more, if you have multiple files open this way, it's good at appropriate points to close them, so you don't start referencing the wrong handles and things like that. So that pretty much concludes lesson 3. Yes, save the changes. We look at our things to do. We covered variables, int and string. We covered arrays. We covered two types of loops, for loop and the while loop, both extremely useful, as are variables. And we covered the stream reader object, which we used with file.openText to open a file, and with actually the stream reader object.readLine method to read all the lines in the file in a loop. And then finally the stream reader object.close to close the file. So that covers everything for lesson 3. I hope you enjoyed it and learned a lot from it. I think if you're not familiar with this material, it's a really good idea to play this lesson over as many times as you need to. You'll get more out of it every time, believe me. And also to write your own programs. As I've said, always write your own programs, because if you're not writing and executing your own programs, you're probably deluding yourself. You understand the material. You really have to do it yourself, and in order to really understand. Programming is a learn by doing discipline. So until next lesson, focus and learn a lot, and I'll see you then.